I get to the full swing, Okay, just want to have some interaction with these colleges. Last time we gave that you should download MySQL software from the GitHub. Okay, right? And I think we want to find out how many of you been able to do that. Okay. For example, you should have cloned the MySQL server software. Okay. If you have actually downloaded, it will be somewhere. Okay. I think I have run this on this machine, so I probably have run that on one of the other server machines that I have. I'm going to get in relational model and then start looking at the relational model. But before that, I just wanted to check, has anybody been able to look at getting the, for example, we actually logged in into this MySQL software and all that. Then we're actually giving you a way of actually doing the Git cloning, right? Git clone, okay? HTTP, right? GitHub, github.com, MySQL. I think this is what the command that was given, The JIT is not here. Probably the JIT, I don't know from where actually I fired this command last time. That's a command that you have to fire, okay? If we actually have the JIT command, okay, and then you should be able to get the okay. So this is what we were actually asking you to do last time. Let me see here. Yeah, this is here. Git clone GitHub. This is the original source code of the MySQL software. Okay, then it will start cloning the MySQL into the local directory. Okay, I think it becomes MySQL server actually. Okay, HTTPS MySQL server. Okay, so if you, I thought it was MySQL not found. HTTPS, right? It is find what was the I think MySQL should work. I guess it is the MySQL part of it. Clone MySQL. Sorry. Let's see if this works. This is a server part of it. I think this should work. Yeah, now you can see this is actually downloading this whole thing. Okay, can you start doing that? Any of machines, can you just write down this and then start doing that? Oh, I think I'm not sharing my desktop, right? Am I sharing my desktop? I'm not sharing my desktop. Sorry about it. I just thought that I'm sharing my desktop. Okay, so this is what is the, no, this is what the command is, right? This is what we wanted you to actually do. This git, are you able to see this now? Git clone http github.com mysql/mysql server. This will give you the whole no server code, whatever code that no the server code, the MySQL, what we were discussing last time, will all come into this. Okay, you can download the whole source code of MySQL server, which includes all the components, locking components, the storage component, which actually creates the files underneath. In fact, we are talking about, given a table, what are the files MySQL program will create, which are the Unix files. Okay, we didn't go deeper on that side. Gave you this as a first exercise. Okay, getting this uh, there are the multiple things that we are trying to teach you here. One is how to work with a version software like Git. Um, your employability skills of working with source software and then contributing to the open source software. In fact, going to the open software is the best way to actually make sure your CV becomes marketable internationally. So the bigger firms in the international firms look for, if you have been able to work on software, if you have been able to contribute to the open source software, to look at if you are employable. Okay, it will take some time, but I want you to do this. Okay, as you can see, maybe by the before the end of the class, this it will get downloaded. Okay, the first thing that you should do is you should download this software. Okay, this MySQL software. Please write down this command here, which I am giving. Git clone http github.com mysql/mysql server. I'm actually doing this. You should also do a similar thing. I actually will show you how to install this in the, once this gets downloaded, I'll also show you how to do the installation. Okay. I'm not seeing any of the colleges have even finished this. Has anybody in any of the colleges were able to do it? What we will do is in today's class, we'll get into relational model. Okay? I'm assuming that the entity relationship model was covered by Jntuk Moocs. Entities are nothing but, see, one of the problems for me is I don't have a whiteboard. I'm still struggling to make sure the board that was sent by Chakravarti, I'm able to use it. Okay. Hopefully, I will become more familiar. I'm trying to write, but then still not up to the. As you can see, I'm having trouble writing the on this board. Okay, I need still a whiteboard. Okay, I will probably use my whiteboard, my room whiteboard, but then it is not very visible. Okay, it's not very visible for people. Okay, but then that's all I can do at this point of time. Okay. So what I suggest is, please do this exercise. As we are doing it, we want you to be familiar with open source software and able to work with open source software. That's one of want the colleges to pick up as a important skill. Okay, very important skill. Let me stress this. This is a very important skill. You people should pick up that skill. Okay. Right. Now, let me get into the relational model a little bit more. Going to get into the entity relationship where I'm actually looking at. Now, I'll stop the desktop sharing and I will actually have used my board board a little bit. Last time I've used that board. I'm going to use that board, and then if you have problem looking at the board, please keep telling me that. I'm actually trying to use my whiteboard. Okay? The whiteboard that is writing on that. Quite clearly for me. Okay. So I'm adjusting this, bringing it closer, so you should be in a position to see what I'm writing on the board. Okay, right? So I'm by the side. So typically, what we are talking about in the relational model. Okay, what we mean by a relational model? A relation is nothing but a name. Relation is nothing but a name with a set of attributes. Okay, A1 to A. Okay? This is what we call as formally a relation. A relation is basically a name, okay, and a set of attributes. An example for a relation is if you look at student, okay, as a relation. Okay, this is equivalent to in the predicate calculus just a predicate having a set of attributes. This relation is same in the entity relationship model, equivalent to every entity. Okay. Now, student a relation formally is a name, in this case a student, and a set of attributes that the student relation can take. Currently, the roll number of the student is one attribute, okay, and the course that student is doing can be the other attribute. Okay, right? Now, instance of this relation, are you able to see the board? Able to see the board? An instance of this student relation. Okay, this is basically you should look at this relation as this is a set of attributes. Since this is called a set, you will not have there is no order. Order doesn't really matter. Okay, this is actually a set. Okay, the additional thing that we will make on this relation is that each of this attribute is basically an atomic attribute, which means that roll number cannot be split, cannot be further split. Okay, so each of this defined over a domain of values. Okay, for example, you can say this is this roll number is actually a character string. Okay, or it is an integer. A course number is an integer. So you will actually define a range of a domain of values that each of this attribute is going to take. Okay, right? So in a simple sense, in a relational model, okay, the relation is nothing but a name with a set of attributes. Okay. Now, each one of this relation can take what are called a set of instances of this relation is basically a tuple taking different value for each of these attributes. For example, in the case of student, you can say the roll number is CSD005. Okay. Student name is Vakul. Okay. That is taking is CS4001. Okay. This is one instance of this relation. It is actually called the student name is Vakul. Roll number is D005, and then course that is taking is CS4001. Okay, this is one instance. There are going to be several such instances of this relation, and this is basically called a set. Okay, this is also a set, which means that duplicate tuples will not be allowed in this. Duplicates will not be allowed. Duplicates will not be allowed. The other important property of this, since it's a set, is that the order doesn't really matter. if you have got another student with CSD006, and you have Vamsi or something like that as the name, and then you bring CS8002, it doesn't really matter if you flip. This is set. Okay, right? Formally, what we mean by relation is a name with a set of attributes, and the attributes taking values over a domain or a defined domain is where the attributes will take the values. Okay, and the instances of the relation are basically the tuples. So this is not a bag. The relation, what we are going to consider now is only a set, not a bag. When we further go forward and we consider the relation mathematically can be a bag also, then we can allow duplicates. But at this point of time, we are going to only we're going to make the assumption that a relation is only a set. Okay, the implications of a relation. Okay, the order of the tuples doesn't matter, and then even here the attribute order doesn't matter. For example, you can also have interchange name, roll number, course, which means that Wakul CS D005, CS4001. So all these are part of this relation now. Okay, what is important is just the name. Okay, name. In a simple sense, the relation can be understood as a table. Okay, in relational model, the relation can be understood as a table. For example, here is a case where the table name is student. Okay, I'll clean this up. I'm assuming that you're able to look at this board. Okay, now what we're going to do is basically what you're going to have here is the equivalent part of this is a table. The table name is the student. Okay, and then you have the set of attributes here. This is like just a table. The relation is nothing but a simple way to understand the relation is nothing but a set of a table where the first row will be the attribute name. For example, here you have the roll number, and you have the name here, and you have the course here. Okay, each of these rows here, other than the first one, indicates the tuple. For example, CSB 006 tuple. Okay, and then you have CS 4001, who the course is doing. Similarly, CS D 008 Vamsi. Okay, and then he is doing CS 800T or something like that. So each one of these rows here is a tuple. Okay, each of this is basically a tuple. Okay, and the cardinality of the relation is the number of tuples that are there in this row. Okay, a simple sense, this is the mapping of a relation, understanding a relation as a table. The table name and all the attributes are nothing but the column names, the instances of the relation, and you have the tuples. Okay, since we are saying that this is a set, we are not going to allow duplicates in this particular relation. If there is a unique way to identify each of these rows, okay? For example, one of the ways you can uniquely identify each tuples is by using the roll number. Okay? If there is a unique way of identifying each of these tuples, that is basically called the key. Okay, right? So each relation can have a key attribute. The understanding of the key attribute is that it uniquely identifies the tuple. For example, two tuples will not have the same value as far as this table is concerned or this relation is concerned. All the attributes put together will form a key for the relation, because no two tuples will have the same values for all the attributes. Okay? For example, in this particular case, if roll number is the key, no two attributes in this set, okay, no two attributes in this relational set will have the same value. For example, there is not going to be another student with a roll number is same number as this, okay, and then no gas or something, okay, then CS4001. This won't be allowed, okay, because this value here is the same, okay. This won't happen, okay. Once you set the key, there's not going to be two tuples which will have the same value as given here, okay. That's basically called the key attribute, okay, is a key. Now, a set of attributes which contains the attribute is called the super key for the relationship. A key for the relation is where the it's also in some books it is also referred to as a candidate key. I'll just drop the word candidate key and use the word key there, but then possible for you to use the candidate key for the relation as well. Okay. Now, in the previous case, I'm assuming that I'm seeing into the chat box, since somebody is saying they're unable to see the whiteboard. Okay, how do I solve this problem? Okay, I'm trying to adjust it, but then I don't know whether anything else is possible other than just I'm using my okay. Let me try one by time using the page that I've got. Switch to the now. Okay, sir. They're saying okay, so I'll just go with it. Okay, right. So any for example, the previous case, the roll number is the key in the student relation. Okay, right, and then you have the name, and then you have the course that the student is doing. Okay, now roll number plus name. If you basically take this, okay, this is called the super key. The super key has the key attribute as its subset. Okay, then if one of the keys is part of the attribute, then we call that as a super key. So you have a key and a super key. A super key is formed from the key. For example, another super key can be roll number course. Okay, this is another super key. Super key has the key as its subset. For example, the key in this case is roll number. Okay, so the super key has the key as its subset. Okay, let me repeat this. I'm going to go a little one by each step deeper by deeper. So basically, the idea is a relation in its simple sense, mathematically, is a name and a set of attributes. Okay, as we saw it. So basically, a relation R is a set of attributes A1 to An. Okay, it can be n attributes. Since it's a set, the order of the attributes doesn't really matter. The relation is identified with the relation name. Each name can be an integer string. The domain can be an alphanumeric. So basically, you can define a domain over which this attribute will take the values. If the tuple, which are the instances of this relation, can be uniquely identified okay, by one of the attribute values, then we call that as a key value. Okay. Another example for a relation can be a teacher. Okay. Each teacher, let us say, has, I'm just using these simple things, but we go to more, more examples later, which will have a more complicated stuff. For example, if you take teacher as a relation and say teacher name, okay, and then teacher date of birth, and then the course he teaches. Okay, right? So you can say this a relation, teacher relation. Now you can say there is a teacher by name uh, Krishna. This can be one instance of this. Okay, right? The teacher name now takes a character string. Okay, the date of birth takes an alphanumeric string. Again, course can be just a character string, but it could also be in an alphanumeric string if you actually put this as a, I don't know, CSDD something, some value. Okay. Now, if once you define the domain, now you can't give teacher, for example, 008 here. That's not allowed because the domain of this you're going to say is character string, which means that the values that this can take is only character string. Okay. Similarly, if you say date of birth is an alphanumeric value of some length, then that's only value that will be allowed here. So each of these attribute has a defined domain over which the values, that attribute can take the values. Okay. Now, what we are seeing further is that each of these attributes, okay, whatever values it takes, they have to be unique. In case you say now, teacher name uniquely identifies in your institute, these are coming from domain. When you define this relation teacher, this is in the domain of your system, academic system. Okay, we have a particular college, and within that college, we are defining all the data that is there in the college. We are defining it. Then we will use this relation called teacher, to store the data about teachers. Okay, teacher name, date of birth, and codes are the attributes that we are interested in storing for this relation called the teacher relation. Okay, so this relation is coming from the domain, the college that we are interested in. These are the data that college is interested about storing about the teacher relation. Okay, it wants to store the teacher's name, date of birth, and course only. For example, pay, all that it's not interested. If it is, then we have to store that data also here. Those attributes also will come. Okay. So when you design the relations, when you come up with relations, you come up with a name which is coming from the domain. The domain tells what you're interested as storing that data. So this basically this relation is a name that identifies, what is the set of data, okay, all the attributes that form part of this relation, whose data you're interested in storing. Okay, so this R and a set of attributes that is what you are interested in. I'm going to tell you, for example, if you say teacher name is unique here, it is going to be unique in your college. Okay, no two teachers will have the same name. Okay, then teacher name becomes unique. Okay, if that is not the case, then teacher name cannot be unique. This is often the case, right? You can't, when you're storing this information, suddenly there can be another teacher with the same name. It can become, Donald or now I think Clinton. Any of these names could be common. So there can be multiple people with the same names. Okay, right? So then you can have, for example, the date of birth here as 12th August 1982, and then teaches software engineering course. Okay. Now, if you permit names to be not unique, two teachers to have the same name, then name cannot be a key value, key attribute for this relation, because they're going to be two couples which can have the same ID, okay, the same value. We're allowing now two this attribute called the teacher name to have the same value, okay, in two tuples. Okay, this becomes now a table. If you basically want to look at this, it becomes a table. Okay, with the column name, teacher name, date of birth, and course. Teacher as the this thing. Now these are the two tuples. Now we are allowing these two tuples to have the same. Hence, this cannot be the key attribute. Once something is a key attribute, it cannot take the same tuple. It has to be unique. Okay. Um, but then, one assumption, valid assumption that most of the domains can make is, even though the teacher name can be common, if you put the date of birth together, teacher name plus date of birth are going to be unique. Most of the time this is true. Even though two people can have the same name, it's possible that the date, as you're storing the teacher information, you can make an assumption that each teacher name plus date of birth, these two put together, are going to be unique as far as these tuples are concerned. So every tuple can be uniquely identified by looking at both these attributes. In which case, the key to this relation called the teacher. Okay, teacher will have the key, which is now teacher name plus date of birth. Both these put together become the key attribute. Okay, this becomes the key for this relation. Okay. A key for the relation is okay. The key for the relation here is teacher name plus date of birth put together. So these are the coming from the domain. Please understand this relation comes from the domain. Now I'm actually looking at from that domain, and these attributes is what I'm actually designing. Okay, these are also coming from the domain. What values they take is also coming from the domain. For example, this college is, takes course, not course names, but then it gives numbers. For example, it will give a certain kind of number. Okay, only integers. For example, if course is identified by just a number 301 or 401, something like that, course will take only integers. Okay, in some other college, let us say there's a kite college where they identify the course with, let us say, with a letter title CS and then 301. Then it will take a alphanumeric string. Okay, in, let us say, Jntuk Kakinada campus, they will give a character string, compiler, software engineering, something like that. So the attribute, the values this attribute is going to get is also coming from the domain. Okay, the domain, what are the values this attribute is going to take? Okay, the domain is also going to tell what is the key attributes, because now if you look at teacher name, if you make the assumption that in Vijayanagaram campus you will never have teachers with the same name, make sure that teachers with the same name will never get admitted. Again, this what I'm saying is, if this constraint is valid in this domain, okay, you can't enforce this constraint. So obviously, no correct thing. But then, if you make sure that your domain enforces this constraint, then teacher name can become a key attribute. Okay. So what is the key attribute? What is the value of this and what is the relation and what are the attributes? All these will be coming from your domain. Okay. These are coming from the domain that you are looking at. Okay. What you're modeling, what is the data that you're capturing. Okay. For example, if you are looking at LIC, a life insurance corporation, trying to now model the data of life insurance corporation. Okay. And the relation can be policy. Okay. Now, what will be the possible this thing there? We will have what is called a policy as a relation. Okay. Here we all academic institution, and we got this. Then what you will get a relation, something like this policy. Okay. What is the policy that this okay. So you can have policy as a relation. And what is the set of attributes that it can have? Policy number. Okay. So this can be a specific number. The policy this can be an alphanumeric or integer depending on how the particular life insurance company is capturing numbers. Then premium amount. This certainly is integers. What is the amount that you will pay, and what is the maturity period? Okay. Again, this may be okay. This can be one of the relations that you may have in case of an LIC system. Policy becomes the table. It will have three columns. The column names are going to be policy number, premium amount, and maturity period. And if we make the assumption, which is a valid assumption, that each whatever you capture here in terms of specific policies, the policy number is going to be unique. Okay? Then the policy becomes the key attribute. This policy number becomes a key attribute for the policy. Okay? Right? This is a simple understanding of the relations. Okay? These are all sort of relations. Okay? Mathematical concept of a relation. Okay? A relation is just identified by a name and a set of attributes. The attributes take values over a domain defined by the domain itself. What are the values that it is going to? Okay. In terms of keys and super keys, also we saw a key attribute uniquely identified by the tuple. A super key is one where it contains the key as a subset. For example, here policy number is the key for this relationship. Okay. And then super key is going to be policy number plus the premium amount, any of this, okay, which contains the key itself. Okay, it is a super key. Okay, super key for the relationship. Okay, right. So having understood the simple concept of a relation, we'll try to look at now the most important concept as part of the relation, which is called the functional dependencies. Does these attributes have any functional dependencies? Okay, this is an important concept, what we see as a functional dependency. Okay, now what is, I think, are there any questions on the simple concept of, please raise it in the chat box if you have any questions on the relations. Okay, right? Relations, keys, super keys. I'm making it very simple and easy. You can identify any number of other relations as well. You know, for example, you can take, for example, a government department. Okay, something like let us say the agricultural department. Some of the relations in the agricultural department could be, for example, the agricultural department could be a particular crop. Crop could be a relation, and you could have, for example, the crop name grown. Okay, and then possibly the kind of you know, the kind of pesticides that that are relevant for that crop, pesticide name that you want to store for that crop, okay, and any other important information that you want to store. These are basically, depending on the domain, you can come up with that. Similarly, if you look at a weather station, for example, okay, um, then you can actually store the weather data. Okay, temperature again is an integer, humidity may be a float. So you can define all these attribute domains, and then you can define the day as a relation. Okay, here instead of this clashing with the name, you can say date here, and date becomes the key attribute. Okay, and then date plus minimum temperature becomes the super key. Any of this can become the super key. Okay, right? The idea of this whole thing is they're going to be, as I'm doing this, I'm also more keen on formally getting to more deeper understanding of what happens if you store this into the system. Okay, for example, no, look at this 365 days. Okay, they're going to be 365 records. No, in a particular year. But if you take since no, since the time we know when we are able to before that it becomes the BC, right? Then you want to go further back no, towards the BC thing. Then you can see how many no, how much amount of this table, how many records will be there in this table. Okay. How many records, that's going to be interesting, because if you basically look at when did really the no, beginning of the universe, okay, is it a billion years? A billion year means basically, no, I'm just now, I know, if you're able to get this data, okay, billion plus a billion into 365, okay, this is only an arbitrary. So there's lots of interesting stuff when you look at the solar system, okay, and then you look at the entire universe, okay, and you keep expanding. The number of stars itself, millions of stars are there out there. Just see a night sky, millions of stars are there. The amount of data people collect about the universe is phenomenal. Okay? And if we just want to store it into any known tables, on a single machine, storing all this data is going to be possible. For example, if you want to store simply a billion records here, a billion plus a trillion records, let us say, there's trillion records are going to be there for this relation. Okay? Now, if you take a trillion numbers, trillion data, and want to store it on your machine, possibly your machine may not have enough space to store all the data. One single machine may not have enough space to store all the data. Okay? So this becomes interesting now. See how this table can grow. And if I want to access any of the tuples information in this tuple, how do I access it now? So basically, this is like now, do I index this table? How do I index this table? What do you mean by index? For example, you have a 10,000 page book. Imagine that you have a 10,000 page book. Each of that page is a tuple. Okay? Whatever record here, let us say there is a page, corresponding page. Okay? Now, the key to the page is the page number. What is date here becomes the page number. Okay? Now we are looking for a particular information in this particular page. Then how do I go to that particular page? Am I going to start from page 1 and keep going to the entire 10,000 pages? It's going to take a lot of time reading this. Okay? A simple file structure where the data is stored sequentially and read sequentially is not going to be useful, because that will create a lot of problem as the data grows. What is people? What does that index will tell you? Given a heading, given a particular title, for example, you're looking for the complete database book. Okay? The database system, the complete book. That's what I'm using for this course, right? By Jennifer Wyndham and Jeff Pullman and Hector Garcia Molina. That's what I'm using. Okay? So that's a very good. Now we want to find out there where the relational model is. The relational model would have been discussed in chapter 3 of the book. So if you look at the index, the first section of the index, it will tell some 85, 90 or some page number. Let's say 92. That means that this particular chapter is starting from 92. So immediately you'll go there. Okay. So basically, when you have this key field here, this is a key which is unique. That is what is going to be used for building an index for this particular table. There's large amount of data that's going to be part of this table. You're going to use the key attribute to index. You build the index for this table. The whole table, how to actually access this table. An index will be built. You will use the index to actually read the data from this table. Okay? How to build this index in indices. For example, there is a P plus tree that's going to be used, and we'll see more details of how the indices will be built for these tables and how the access becomes faster. And that's one of the reasons why I want you to actually download that MySQL, store it, so that some of the exercises like changing this indexing is possible for you. You can build your own index, okay? A different kind of an index than what is being done by the defined algorithm. Okay? You have a specific need for a different kind of an index. You can do that, implement it, and see the performance of this system for yourself. So that can become an interesting project. Okay? You are not actually no longer just studying these concepts. You have a new idea now. You don't need to build the whole database system. Only the index part you will change. How they are indexing, you're going to change and see, is my indexing going to be better for my data? Then go and then change that and rebuild that index as you require it. Okay? They all become interesting. If I'm not able to store this table in one machine, I'm going to store it on multiple machines, which becomes a distributed this long table. And then how am I going to access it? That becomes a distributed database. So the whole concept, the gamut of concepts that come in from this simple idea of just having a relation and a table are quite a few. And then we don't get into it. All that we're trying to do is open up a little bit for you right now and give the basic concept and tell you how this opens up. As we go deeper into the class, we're going to do some of this by saying that now how to rebuild an index, or what happens if it becomes a distributed database, how we're going to handle those queues. We're going to discuss that as right. So I think the extra stuff that I'm talking about from these simple things that we are looking at. Okay. Suddenly, I think some of you should practice, going in the night outside, okay, and then looking at the night sky. Okay, looking at the night sky is a very, very fascinating thing. Okay, it also humbles us, because that tells there's one president who used to every day come out and then look into the sky and say in front of the sky how small we are. All these stars up there, how small we are. And solar system also has enormous amount of data. For example, discovering new stars is always an interesting problem for people when they see this night sky. There are few places on Earth where the night is very beautiful. Okay, so try to look for those those information, and then be excited about about the whole nature and where we live and live, and also the need to preserve all of it for the future generations. Okay, right. That's a side. Trying to also excite you about other things in life besides database system. Extremely exciting, but there are lots of other things also in life which are so exciting. Okay, we don't have time for all the exciting things. That's since life is so short, so it should not be wasted, in useless pursuits like watching useless movies for a long, for long hours and all that stuff. Okay, right. Now, given these relations, right, we have the next important concept. Understand the relations is what is called the functional dependencies. Okay, it is also called the functional dependency attributes. It is also abbreviated as FD. So these are called FDs. In a simple sense, the functional dependency is called an FD. Okay? Mathematically, the FD, functional dependency between two variables, is depicted as, for example, y is functionally determined by the variable x is written as y is f of x. So there could be a relation where given an x value, you can determine y value. For example, here, if the function y equals to f of x, this function is x squared plus 1, given a value for x as 2 or x, y is not independent. Y value, given x value as 2, okay, now this becomes 2 squared plus 1, so y can only take a value of 5. So we say y is functionally dependent on x. Okay, between variables, this is what we mean by a functional dependency. X determines the value of y. So if you give a particular value for x, that determines what is the value of y. It's not independent, but functionally dependent on x, the variable x. This is mathematically, this is what we mean by a functional dependency. Okay? The same thing exists in a relation between attributes, but it is slightly different from what we see as a mathematical functional dependency. Okay, the values are not calculated like this. A set, a relation is a set. So when we want to understand the functional dependencies between the attributes, what it means is, okay, the FD, what it means is, if two tuples, for example, there is a relation of B, okay, A is the attribute, B is the attribute, okay, there's the relation R. Now there are two tuples in this relation where A takes the value A1, B takes the value of B1, okay, A takes the value of A2, B takes some other value of B2, okay, like this. Now what the functional dependency, if you say that functionally, okay, A determines the value, okay, right? That means B is determined A, right? This is what we mean by the functional dependency. Then in two attributes, if the A value is equal, for example, if there is another attribute A1 here, okay, then they have to necessarily agree on the value of B. This is the functional dependency between A and B. For example, what we say is, in this relation, there is a functional dependency of A determines the value of B, then it is not possible to have a tuple where the A value is same, but B value is different. For example, here, it is not possible to have a tuple with a value. If there is a functional dependency, this will not be possible because in both these tuples, the value of is same. What it is telling is the value of A now determines the value of B. Okay? Now this is not a function, the mathematical function given A1, I'm actually calculating mathematically B1. That's not what it is. This is tuples. This is taking a value. The value has to be the same. Okay? Right? This is what we mean by the functional dependency. This is equivalent to saying, here is a case where there are two attributes A and B. Now A determines, the value of A determines the value of B in terms of the tuples. What value B takes is determined by the value that A takes from the, okay? Let us go a little deeper and understand the functional dependencies. Okay, this is basically in terms of the set values that the relation is taking. Okay? Let me repeat this again. Okay? I'm just going little deeper here. Let me just take a minute and get some water. So the where we say that student relationship and you have a roll number. I'm just taking the same A and B, roll number and name. Okay. Now in this, if you say the roll number functionally determines the name, okay, right? This is a functional dependency, FD, between the roll number and the name. Okay. Roll number determines the name. Okay. Now, if the tuples that are there in this, let us say I have a roll number CS001D5, okay, and the name is Swati, okay, right? Then let us say I have CS001D8, Puja, okay, okay, very good work. Okay, then we have another this thing CS005P9 Soumya. Okay, so like this we have this. Okay, yeah, right. So what we're saying here is, let us say what is not permitted by this dependency, functional dependency is, okay, if the value of roll number is same D5, now you can say you can't put a name like Maya or something. Okay, this is real Maya. Okay, if they agree, the roll number CS001D5, CS001D5, okay, they agree. These two tuples are agreeing on the A, which is the roll number. Okay, then they also have to agree on the name. Okay, if there is a functional dependency, because A determines the value of B. Okay, this functionally determining the value of. I'm not actually mathematically writing something like, if you actually put CS001, it somehow produces this character string, Swati or something. These are basically take the value. It's not mathematical functional dependency, but then the value dependency. Okay, given that in your domain CS001D5 as this 40, okay, CS001D5 Maya will not be allowed. So this is not possible if there is a functional dependency between roll number. Roll number functionally determines the value of name. Okay, this won't happen. This also has to become Swati. If they agree on the value of this, then it also will have the same. Of course, now by set relationship, this becomes a duplicate, so this will not be allowed. So by a functional dependency A to B in a simple relation like this, you know that roll number determines the value of name, and hence roll number becomes the key for this relationship. So functional from the domain. Example, the domain tells what is the dependency between the attributes. Okay, the functional dependency between the attributes. Okay, right. Let me make this little more clearer for you. All these relations are coming from the domain. The attributes are coming from the domain. What value the attribute takes comes from the domain, and these functional dependencies are also coming from the domain. Okay, right? The FDs are also coming. The functional dependency. What is the dependency between one attribute to the other attribute is also coming from the domain. Okay, right? Now what we are going to do is, when we are trying to come up with relations, we are going to look at essentially the relations, the attributes, and the functional dependencies to see whether whatever we are coming up as tables or relations are good or bad. That's the key thing to understanding the whole relation and why these functional dependencies are important. For example, if there is no functional dependency, now let us say there is no functional dependency. Okay, I'm saying in my domain there is no functional dependency between roll number and name. Then this will be very much possible in my domain that I can have some other value here which says this can be Maya. Okay, which actually means that I can't use this roll number to uniquely identify the data or the tuples in my system. Okay, because given CS001D5, I no longer can say this is the student name, because both Swati and Maya are possible in this roll number. Okay, so there is no functional dependency between roll number and name, which means given a roll number, you can't determine uniquely the other name. This is like saying, in the mathematical sense, earlier I wrote y f of x, given x, I know given x is 2, y is 5. Okay, given the same 2, if y also takes, and there is no functional dependency between x and y. That is the case here. Okay, there is no functional dependency because given the roll number, the name can take multiple values. Okay, not just taking a single value. If there is a functional dependency, when x takes 2, we said y equals to x squared plus 1, then it's actually 5 only. You can take the value of 5 only. If there is no dependency, when x takes value of 2, it can be 5, and it takes 3 also, it can be 5. So there is no dependency. Y takes its own value, x takes its own value. That's if the two attributes are independent here. Roll number can take its own value, set of values, name can take its own values. So what we say is there is no functional dependency between the attributes if this is the case. Okay, right? If there are functional dependencies, we need to look at them and we need to see whether they are captured adequately into our relations and what kind of function happening in our system, of database. Okay. A lot of other stuff that I'll get into, but then I'll probably go into deeper aspects of functional dependence in the next class. But what I'll do now is I'll sort of show you. See, the whole idea of doing this class is also, along with the theory part, I'm also doing a lot of practical part as well. For example, now to just tie this whole thing to the practical part of things. Okay, what we are doing. Okay, in terms of the relational this thing. Are you guys with me? Any questions? Any questions from anybody? Raise your this thing, okay? Um, Desktop now. Okay, I'm just sharing the desktop. Yeah, so this is one of the running examples that we are going to use. Okay, I hope you're able to see this. See this example. Now, what this system says, for example, this is the starting part of the domain. For my database domain, database design, the domain is important. Okay, it always starts with a higher level problem specification, right? For example, in this particular case, I'm trying to design a database for IIT Madras rate contract system. So I'm just saying IIT Madras rate contract system specification document. Okay, this is the problem. This is a domain. What is the domain for me? Now all the data comes from this problem domain for me. Okay, this is the problem that I'm going to solve. This is a problem that where I'm trying to design my database. So I need to first this higher level problem or data, no, whatever data I'm getting, how kind of data it is, how I'm going to capture this into my system. Okay. Now we saw student relation, teacher relation. Like this, we have to now worry about how the data comes from this domain. Okay. At a very high level, you can see what this problem is all about. IIT Madras has a rate contract system for purchase of computer systems by its various departments and faculty. So there is a purchase procedure. The purpose of the rate contract system is to allow the departments and faculty to purchase the computer system rates, so that individual faculty and department need not go through elaborate purchase procedure of getting quotations for the computer systems from different vendors, establishing the lowest price and placing the orders. For example, I want to buy an Apple Mac Air notebook. Okay, this is a laptop that I want to buy. In IIT Madras, what you need to do is you need to now go to 8 vendors who can supply this machine, and then take among them the lowest one has to be no, whichever is giving at the lowest price. That's what we have to purchase from. This is called the purchase procedure. Okay. Now we have about 500 faculty members in the institute, and many other staff, project staff, and all that. Okay, we have about 8,000 students. Now, what we want to do is every 3 months, for whatever systems people want to purchase, we want to take the quotations from all these vendors. Okay, I'll spend some little time explaining this procedure, because this is what I'll use as a running example for my building the entire database, right? So what happens now, the way this works is, for example, we say we have a list of computer items that we want to purchase. For example, i5, blah blah, this level of monitor, all that. What are the different kinds of computer configurations? Similarly, printers, color printer, okay, multifunction printers, MFPs. In that we have laser printers, we have desktop printers, we have all kinds of printers. Similarly, we have all kinds of notebooks. Apple notebooks, IBM notebooks, okay, different kinds of notebooks, HP notebook, right? So what we generally do is we actually give a quotation, open tender, we publish it in the newspaper, saying these are all the configurations that we are interested in purchasing. Okay, then all the vendors who are interested in this to IIT Madras, will give by the specified date, okay, or their quotation, saying that this is the price at which we can supply these items. They used to give that in a sealed tender, and then we open at a designated time. and then tabulate all of it and take the L1 first in that, and then then we say that people can purchase automatically with that vendor at that price. They don't need to go through any other procedure after that. They just need to go and place the order directly. Any of these 500 faculty members can place directly the orders for those systems with those particular vendors. Okay, that is a procedure. Now, a manual procedure, we used to have the whole thing manual. For example, we used to publish it, people used to give manual sealed documents, and we used to open it, and we used to tabulate it and then decide on the L1. This used to be very, very time consuming, extremely time consuming. For example, if we open the tender at afternoon 12 o'clock, the reading out all the L1s, whatever prices of each other went to come to a conference hall, 20 of them, and we used to read out the price of each of the codes. Okay, this used to go up till midnight. It used to start at afternoon 12 o'clock and it used to go up to midnight. Okay, that's the time when I was the chairman for this committee, which was doing this whole work, and I decided that this procedure cannot go on like this. We have to build an automatic system, database management system that automates the entire procedure. No paper, everything should work, automatically. And that's the time when I sat and started designing this database. So this is a result of that work. Okay, so I have deep knowledge of the domain, and that's also became a case study for me to teach for the database systems course. Whole system is built and it is in operation now for about 10 years at IIT Madras, and we do reverse auctioning. No manual papers after that point of time. After this was designed, developed, and then given. Okay. Now I use this as a case study, and I also all my assignments are based on this system that was developed as part of the thing which I have developed. Now that became part of the course. My first lecture on NPTEL lecture actually talks about this this system that was developed as a case study. Okay, you can also watch the NPTEL. Now, what we are going to do as we go further. For example, you can see there is a more elaborate description of this, in which I will share with you people. Okay, and then this gives reasonably good idea of how the whole system works. What we want you to do as an exercise 1 is that we will share this, and you have to come up with the ER modeling for this. Okay, for this particular specification, you have to draw the ER model for this and should send it to us. Okay, right? That's the first assignment on ER modeling. Then once you have the ER modeling, convert this ER model. We showed you, for example, the working system which we've shown you earlier. Okay, is the system that was developed. Okay, now okay, so what we have here is, for example, you can see the whole thing here. Okay, this is something that we were talking about, right? When we want to go into this rate contract system, you can see this is the developed computer rate contract and CPC meeting details. For example, whatever is approved rate contract thing, you can go here. You can go into computer system configuration, and you can take the specifications and okay, and for example, you can search using the specification and vendor name. And you sub this, you get all the approved vendors here. These are all the vendors that can submit, and then you can say submit. These are all the configurations that they can submit. For example, to system. These are all Fujitsu. You can see here Fujitsu is the supplier here. Then and then these are the specifications. Intel quad core Xeon 352A with 1 CPU, 2 GB DDR RAM 2, and all that stuff. Okay, SATA. This is a specification number. This is the specification number. 70 among all the specifications that we have. Okay. Now, for example, why are we trying to look at this? From here, once you have the ER model, you can go and then design all the relations that are coming from this domain. For example, one of the relations that I've shown you previously, okay, for example, what is the relation that I've shown you? The relation that I've shown you is the vendor table, for example, which was stored in the MySQL. Okay. Okay, here you can now say, we'll get into this. Okay, we will get into database change, show tables. Each of these become the relations. Now, what we have seen that each of these becomes the relations. Now, users is one of the relations. Now, the user relation will have ID. This is the company ID, then the company name, then the username and password. These are becomes the attributes. Okay. Now, what is the relation that is coming from this system? The relation that is coming from this systems is the user relation. This is nothing but the table. Okay. The attributes are ID is the attribute, company is the attribute, username is the attribute, password is the attribute. What is the domain values that it will take? ID is an integer, 11, no, number integer. You can see 11 here. Okay. Company name can be varchar of 50. So it can have 50 character length string. Username and password for the company to log in into our system. It's a varchar. It can take no 11 no okay, 11 character thing. Password is again varchar. It can be a 50 character string. Okay, this is basically the relation. Users is the relation. These are the attributes. This is the domain values that these attributes can take. Okay, you are additionally going to say whether these attributes can take null values. For example, if ID can be null, you're going to say no, this can never be null in your domain. ID should have some value. Okay, this is a constraint that you are actually no imposing now for domain. Company ID can never be null. Company name can never be null. Company use can never be null. Password can be null. That means you need not give a password, but everything else has to be null. Okay. Now, what you are saying is the company names are going to be unique. That's why it becomes a primary key. No two companies will have the same name. So it becomes in your domain, this becomes a key. Okay. Similarly, username for logging into your system again has to be unique. Two companies cannot have the same username. So again, it's a primary. Okay. Right. So this default value for the company ID is 0. If no value password, the default value that it takes is null. Okay, this is how the relationship is defined. Okay, this is how in the database system a relation is defined and it becomes a table. Okay, whatever we saw as a relation there, this is an example into this system. Okay, this is basically the company address table, company information table, where you have the company is called the users relationship. Users have an ID, company, username, and password. These are the attributes. These are the domain values. Okay, these are the other things that it actually takes. Okay, right? This is a practical okay, of, for example, you can go to relationship notebooks. Okay, and see what is the describe notebooks. Notebooks have lot of other attributes. For example, there is a serial number which is based on that becomes the primary key, then processor type, CPU, blah blah, all other. So these are all become the attributes of the notebooks relationship. Okay, some of this we are going to look at as we go deeper into the class. We are going to look into this, and then what we are studying there, we're going to look at the concepts into this fully developed database system, and our exercises will also be based on this. Okay, right. So I think I'll I'll stop here. Okay, there's a chart here. Yeah. I thought I'm sharing. Oh, did I not share my desktop? Oh gosh. All I did has gone off, is it? Did I not share my desktop previously? Forgot to share my desktop, is it? Then you should call me on my phone. Oh gosh. Whatever I'm explaining, I didn't share my desktop. That's quite. I think I'll probably repeat this in the thought I was. You could have pinged me. I think you should call me on the phone because sometimes I get in there, I don't see the. I'm sorry. I think now no, I just went ahead without sharing my desktop. I think I'm sorry about it. I think you should call me on the phone because I got into it and didn't realize that I'm not sharing my desktop. I'm sorry about it. I went into it and then I think I did quite a bit of it without really sharing my desktop. I'm sorry about it. Sorry. Okay. I won't be able to redo it right now, but I think I will sort of cover it up in the next class. Okay. The last part is important because I actually took the practical example of what I did in the in the first part of the class by showing actually how they turn it into relations. Okay. No, I think if you show my phone number in case such a thing happens where I forget to share my desktop and start doing this, you should try to, because chat also I didn't see because I got into the desktop, I didn't see your chat box. Okay, sorry about it. Okay, right now I forgot to share and then went about talking. Okay, yeah. Okay, there is some how to know about the number of primary keys possible for a given relation from the FD. We're going to do that. See, we have just only introduced the FD part, functional dependencies part. Okay. Now, given a relation, okay, given that no, given a relation in the FDs, how to determine the key and then what are the normal forms, all that we're going to discuss as we go further into the class. Okay. Right now, you keep that. We have only discussed functional dependencies. We didn't actually get into how to identify, given the functional dependencies, the keys. I will do that in the next class. Okay. Okay. Any other questions? If you have no questions, I think I will actually stop here and come back in the next class. Okay. I might go a little deeper. Let me see if anybody else is on the user thing and I can go. Uh, yeah, I'm not able to get into any of the other things. That's okay. Okay. So that's fine. Yeah. So I think we'll stop here and come back. Okay. I think sorry that the last part of the thing I actually didn't put the desktop sharing. So some important part of it is actually missed out. So I will do that in the next class. Okay. Yeah. Okay.